Okay, welcome back everybody. So today's topic we're looking at is a different part of algebra. It's something called inequalities. Now this is new, we've not done this before, so let's look at this topic and see if we can make sense of it. So an inequality is a mathematical statement that uses the following signs that are listed there. So it's similar to a mathematical equation, but it doesn't use an equal sign. It uses the less than or less than and greater to or greater than and greater than or equal to signs instead of an equal sign. So all this does to change the answer to the equation, or the inequation in this case, or the inequality, is just make the answer to the statement more than one number. But it's still a problem we can solve. So it's no different. We're not going to solve it in any different way than what we've done with normal algebraic equations. We've just got a few different rules. We can also plot an inequality on a number line. So we all remember what a number line looks like. It's just a straight line with arrows on either end with the numbers marked on it in order. Usually there's one between each one, but of course there can be more than that or less than that as well. So this is the type of ways that we would draw an inequality on a number line. So let's have a look at them. What's useful about showing the answer to these on a number line is we've got more than one answer here. Obviously, if we were showing the answer to an equation on a number line, it would just be at one point. It would be one answer, there's no more than that. So that's not particularly useful to us. But when we're plotting an inequality, we're working with a range of numbers for the solution, which is really useful to show on a number line. So let's have a look at how it is. So we use circles to show the starting points or the finishing points of our what's called a solution set, our set of solutions for a particular inequality. So when you are working with an inequality that has a greater than or less than sign, and notice these here, greater than, less than symbol. So in other words, it's just a straight symbol and doesn't have that extra line which includes equals to as well. We use an open circle. So I'll just rub that out. So you can see down below there, we've got an open circle as our starting point. And that's just a starting point for our answer here. So in this case, x is greater than 1 is our inequality that we're going to plot. So our starting point is 1. So we draw the open circle there, and we want all the numbers above that. So we draw a red line to the right-hand side for the numbers above it, and you want an arrow on the end of that line because an arrow means that the answers just keep going as well. Now, if we wanted to plot x is less than 1, we would do it in a similar way, but this time we're going to draw the line to the left-hand side, again with the arrow showing we want all the answers keep going, but we want the answers that are less than 1. When it includes a greater than or equal to or less than or equal to sign, these here, you're actually going to have your starting or finishing points with a closed circle. So it shows that it includes that answer as well. The equal to means that answer is part of your solution set as well. So if we were plotting x is greater than or equal to 1, it still starts at 1, but this time we've got a closed circle and we want all the values above. And obviously the opposite for x is less than or equal to 1. Closed circle and the values below. So greater than or less than just means that the starting number is not included, whereas greater than or equal to or less than or equal to means the starting, nice typo there, starting number is also included. So that's the only difference between the two. You've seen those signs before, but just a reminder if you're not sure what that means. And that's what the closed and open circles show the difference between. Now, we could also have an inequality that has a bottom answer and a top answer. So when we've got a set of numbers that have both an upper and a lower answer, you would plot it in this way. So for example, we've got -2 is less than x, and x is less than or equal to 3. So -2 is our bottom answer, +3 is our top answer, but because it's just a less than sign, we don't want a closed circle. We just want an open circle as our bottom answer. But our top one is a closed circle because it's a less than or equal to sign that we're working with there. And we want all of the values in between. So again, we show the line. So how do we know what to plot? So we can actually solve inequalities in a very similar way that we solved equations. But we're going to have multiple answers this time, or a solution set rather than one answer. But there's a few rules you have to know when you're working with linear inequalities rather than the linear equations that we've been working with. So let's have a look at what they are. So all numbers that satisfy an inequality are called a solution set. So that's just all possible answers for the problem we're working with. Here is one that's important. If we multiply or divide both sides of an inequality by a negative number, it only works when it's a negative number, we have to swap the inequality sign around. We have to swap it to the other way. If it's less than, we have to make it greater than. And I'll show you an example with it. Here's some examples here. 5 is less than 8, but negative 5 is greater than negative 8. So you can see if we've divided both of those by negative 1, then we have to actually swap the sign to make it true. The other rule we have to remember, and it's important when we work with these, if we swap the sides of an inequality, so in other words, if we moved our x from the right-hand side to the left-hand side, as we're supposed to when we write a mathematical answer, then the inequality sign gets swapped around as well. So hopefully you can remember those things. If you're dividing and multiplying by a negative, you swap the sign. If you move the unknown to the other side, you swap the sign as well. Swap the operator. Okay, let's give some of these things a go. Okay, so we're going to work through these 4 problems. So find the solution set of these inequalities, then graph the solution on a number line. Okay. Whoa. So A is x minus 3 is less than 7. So we need to get all of the numbers on the right-hand side. So the way we solve an inequality is exactly the same as we would solve an algebraic equation. So you don't do anything with the sign, you pretend it's an equal sign as you're solving, and we need to add 3 to both sides to get the negative 3 away from the one side. So x is less than, see I've not changed the sign at all, and we're going to add the 3 on. So in this case, x is less than 10. Now, I've just added, so remember with adding and subtracting, we don't swap the signs around at all. So I just needed to add my 3's to both sides. Now, let's plot that on a number line. Obviously, you should be using a ruler, but it's very difficult on the screen to use a ruler and have it work well, so I'm not going to do that. Just going to try and draw as straight as I can. Now, you don't need all parts of the number line. I only want values less than 10 here. So I'm going to plot some values either side of the answer that I want. And that's why I've chosen 7, 8, 9, 10, 11, 12. Okay, now I'm going to change to a red pen. You don't have to do this. Oops. But you can. Okay, now x is less than 10. It doesn't have an equal sign, so I want an open circle to start. And I want all of the values this way, down to the left. So that is it, plotted on the line. Now, the last thing I should be doing though is actually writing the name of my inequality on there. Really what you're doing is graphing, and remember whenever we do a graph of an equation, we would actually write the equation on there, labeling as well. So it's no different here. So that is it. That is the answer for A. We've solved it and we've plotted it. Let's do the next one. 5 minus 2x is greater than 3. So again, we want to collect our numbers. So I need to take 5 away from both sides to get my numbers together on the same side. So minus 2x, 3 minus 5, minus 2x, minus 2. Okay, now I want x, I don't want minus 2x. So I need to divide both sides by negative 2. And remember the rule is if you divide or multiply by a negative number, you have to swap the sign. So in this case, I need to write my sign the other way because I'm dividing by a negative number. Probably a good idea at this point to be writing this step down. So negative 2 divided by negative 2 is of course 1. So x is less than 1 is what we're after here. So again, let's plot that. Oh, that is not good. Seems to have settled. Oh no. Not okay. Just bear. Okay, not sure what happened there, but I think it's okay now. So again, I'm going to, whoa, very bad line, was very much not straight. I'm going to try and draw a straighter line, and let's plot this on a number line. So again, what you put here is up to you. I'm just going to put what fits and includes the values that I am after. So, okay. Just trying to get to my pen, draw a red line. Now, x is less than 1. So again, I want an open circle and I want all the values that way. Wow, so bad. Let's try that one again. Try and get a straight line. Well, a little bit better, but not awesome. If you guys use rulers, you will be able to get a straight line, no problem. So again, we should label it. X is less than 1. Okay, let's do the last two, well, that we've got here. Back down where we need. So C here is d over 11 minus 3 is greater than or equal to minus 11. So in this case, I have to move that negative 3 first because it's not part of my fraction. So I need to add 3 to both sides. So I'm just adding, so nothing has happened with the change in sign. So d over 11 equals minus 8. Now I need to multiply both sides by 11 to get the d on its own. So d is minus 88. I have not moved my sign, I have not changed that because I have not multiplied by a negative number, I've multiplied by a positive number, so it stays exactly the same. Okay, let's try and draw a number line here. So I'm going to go up in 2's this time, simply because I just think it will be more useful. Okay. Now, oh, I hate it when it does that. I need to go back and fill them in. 90 minus 88. Now, let me see if I can get my red pen up again. Doesn't like doing this when I'm screencasting. Okay, now d greater than or equal to negative 88. So negative 88 is our starting point and it is a closed dot, closed circle, because we want that number as well. And we want all of the numbers above that. So we are, in this case, going to the right-hand side, because right is always, oh, not having much luck today. Right is always the positive. So let me see if I can change my pen back again. Oh. And we want d is greater than or equal to minus 88. So I'm going to do the last one. I'm almost out of time on the recording. I'll do the last one here. I'll write it up. Any questions at all, you let me know, but it won't be part of this recording. But what we're going to do after I've done that, so I'll write that in a second, you're going to do exercises from exercise 2G, and your homework for the next lesson is watch the using formulas screencast and take notes. Okay, good luck.